Oh, hey.
Oh, hi. Monaco here.
Milks. Mister, get off your phone.
I'm sorry. Taking care of some business.
All right.
Let's move it.
Yeah, let's do
Vocab.
Vocab.
Crush it. What's a mole?
Okay. A mole is a unit of measure in chemistry. Helps me count little things.
Yep. Pause it. Write down your definition because we're moving fast now for you guys.
Yes.
Next one.
Avogadro number.
This is a special number that Amadeo Avogadro came up with. It is like a dozen is 12. And a mole is 6.02 times 10 to the 23rd. We're talking about atoms, molecules, particles, whatever. A mole of something is that many.
Yep. Don't get hung up. It's that simple.
Next.
Gram formula mass. Now, this is where I'm going to take the masses that we learned on the periodic table, the upper right-hand corner of the tiles. That's them. And then we can convert those into grams for that particular element in moles, though. So one mole is an atom many grams.
And in this way, we can take a mole of something and we can count atoms by putting them onto a scale. Simple. A coefficient in chemistry is just like a coefficient in mathematics. It's a number before a variable.
That's it.
Our variables in chemistry are chemical compounds, and our coefficients are the number of molecules in that chemical compound that are going to get reacted.
That's simple.
Or produced.
There you go. Subscript, super important. We cannot be getting this thing wrong. This is those little numbers that come after the element, and that's the hang up. It comes after the element. So in the H and the O, it's really easy, but in the H2O, we could get confused. And I did see some of those on a test where I'd see one H and two O's. So we got to get this right.
Means there's two hydrogens,
Yes.
not two oxygens.
We got to get this right every time. We cannot afford to make those simple errors because it's going to really affect the gram formula mass.
Limiting reactant. Love this picture, Milks.
It
Talk
does
about
tell the
Franks.
story. It does tell the story.
Chemistry is a lot like cooking. If you're in the kitchen and you got a recipe, like a chemical equation, and you're trying to make dinner, but you run out of one ingredients, you're going to be limited in the amount of dinner that you can make.
Right.
In this picture,
We run out of hot dog buns.
and so I can only make 4 hot dogs and buns. I got leftover hot dogs. The limiting reactant, in this case, is the buns. I run out of it first.
Right. And
It happens in chemistry too.
It's a great analogy. We just got to figure out which one of the reactants we run out of.
Yep.
All right. Conservation of mass is just what it means. Conservation is saving.
Yep.
So we're going to find out in these chemical equations that we use the number of atoms we have as product or as reactants we have to have as products. I can't create them or destroy them, but I can switch them all around.
And swippity swappity.
And that's what a chemical reaction does. So, but they got to have the same number.
Mhm.
Okay. Good.
Now, balanced chemical equations observe the law of conservation of mass. They show what atoms of what type were there before the reaction and after the reaction, and they best match up. Because if they don't, that means you didn't balance your equation right, or that this particular equation is disobeying the laws of the universe.
Right.
And we don't like that.
I'm not going to go too deep, but I could give you this problem without those coefficients, that 2 to 3 to 4 and the 3 that are out in front,
Get rid of them.
and that's all you're allowed to add when you balance equations.
We'll teach you how to do it.
Yeah, that's it.
Yeah. Don't get too deep. We're going to run out of time.
I love it, though. I love it, though. Synthesis. Synthesis is to make.
To make.
Synthesize, to make. So take two things, put them together, like us, and you make something.
Yes.
So like we are making something now. We're going to make one video
Mhm.
with 2 teachers.
You see, we came together to do this for you, just like next slide.
Yep. Oh,
At the end of last year, they pulled us apart.
they did.
So
Yeah.
they broke it up a good thing. So we had to come back together and said, no. I'm going to do it anyway.
We're doing it anyway. So
Mhm.
decomp, go ahead.
Break apart.
Break apart.
That's
Take
it.
one thing, break it into 2.
Next.
Good. This is where things get a tricky.
It's not that bad.
It's not that bad. It isn't that bad. So single replacement, I'm going to replace one thing, single.
Swap.
And in this case, the A is replacing the B.
Right. It's like, you're in my seat. Let me have it back. Oh,
Right.
all right, fine. And then I go and sit down, and there we go.
Yep.
Single replacement.
There you go, single replacement.
Double replacement.
Is I see the difference right there with the A, B to C to D,
Mm-hmm.
right? Because now there's a D.
They swap in a circle.
Yes, 2 things. Because the other things did a circle too, but notice this time they both swap.
Mhm.
They're 2 compounds now. Each compound did a swappity swap, double replacement.
That's
Good.
it.
Good.
Molecular formulas, my favorite. These formulas show you the true number and type of atoms that are combined in a particular molecule, hence the term molecular, and formula being the count. So
Right.
there you go. I love molecular formulas.
Right.
Don't like so much these next ones, Mr. Milks.
Yeah, well, empirical aren't that bad. Empirical is just basically the reduced form. So I can break that P410 down into this P2O5 because I can divide both of those subscripts by the 2, and it's a reduced form. And if you look at the fourth one down, I got a 5 and a 12 and a 1, and I can't reduce that anymore. So that one's already in the reduced empirical formula. We'll see where this comes into play, but you need to know the difference between a molecular formula and an empirical formula, and then mathematically how to use them.
It's not so difficult once you get the hang of it.
No. And percent's pretty easy. Overall percent is just part over whole.
Yeah.
This time we're talking about mass. So
we're going to do a lab on this, percentage composition. We're going to find out how much water is locked up in a particular crystal. And it is exactly how we calculate any one of your given grades.
Yeah.
What part did you earn, divided how much part was there, times it by 100, you get a percentage.
Yep. We can do it with hydrates, or we can do it with atoms in a compound.
Yeah. It's the same process.
It's the same process.
Now,
Products. Reactants. Oh, boy.
better burn this into your barium.
Yeah, this is one of those things.
My God.
This is one of those pet peeves I have as a chemistry teacher when students can't tell the difference between a product.
Which
and a
one's a product, mister? It's on the right-hand side. The arrow points to what you made. You produced something.
Yeah, you produced a product, so it's the end piece. The end piece is the right-hand side of the arrow.
Because we read left to right.
Yep, and we end at the right. It's that simple.
That's it. And reactants, that's what you had started with. You could call it ingredients,
You could.
but we chemists call them reactants.
Because they are the pieces that will react.
To combine, in this case, which is a synthesis reaction, look at, you got two different things combining to make one. Two reactants combine to make one product. That's a synthesis.
Yes.
Good
Polyatomics. This
old
is-
table E.
Yes, this is when in doubt, check E out.
Yep.
This is something we all are familiar with by now. We know what a polyatomic ion is, but they were going to come into play heavy, this unit. And that's in the 2 words from now. But
Yeah.
first, let's do hydrates.
Hydrates. These are chemical formulas that have water attached to them. There's a
Yes.
special dot. It looks like the multiplication dot in math. It's not multiplication, really.
No, it's like a ratio.
Yeah.
For every,
It's like
the first one. For every
Right.
one of those, you got 2 of those.
Right. For every one BaCl, it comes with 2
Water.
H2O.
For every 1 iron sulfate, I have 6.
Oh my gosh!
Waters.
I'm gonna get carpal tunnel over here, Mel.
Oh my God.
I'm gonna stop.
Yes, yeah.
So
Yeah.
it's a special way of
Just
showing
that there's
that
water hidden inside.
water's locked up in the crystal.
Yep, that's all. And then parentheses, this is important, and this works backwards when we learned in algebra.
Yep.
Because if you look at the first example here, I got parentheses around my NH4, which is my ammonium polyatomic ion.
Yep.
And then I got 3 of them.
Right.
So that's 3 NH4s,
Mhm.
and it goes backwards distributing instead of forward distributing that we're used to.
Mhm.
So that's all.
So yeah, they're there to show you that there's groups
Of
that are
polyatomics.
special. There's special groups. Learn how to count them.
Yes. Yes, and that's it. That was pretty quick, guys. Gotta be honest.
I'll
8
have a
minutes for
little Google
vocab.
Classroom assignment for you, probably asking questions about terms or something, some pre-research, kind of like homework number 1.
Yeah.
And
I might not. Who
get
knows?
ready for your vocab quiz.
Yeah, I think collectively we'd like them done a little earlier.
And I don't want as many retakes,
No.
really.
No, my kids have been pretty tight with once they take it, because they don't take it till they're ready. It's that it shouldn't take you a week and a half to be ready.
It's Thursday. Every Thursday, there's a vocab quiz available or a retake. So be ready. You
Okay.
can plan on Thursday in my class.
Nice. Wednesdays in my class is the
Quiz day.
reference table quizzes. So
See ya.
See you guys.